Hi there, welcome to another math class. Today I'm going to be showing you how to prove these trigonometrical identities. So your student asked for help in this and I thought it was going to be helpful to share how to solve problems like this or prove it. Let's get right into it. Start with the first one. You have to prove that what is on the left hand side, which is sec squared theta plus cosec squared theta, is equal to tan theta plus cot theta all squared. Alright, I'm going to start with the left hand side. Now the left hand side is sec squared theta plus cosec squared theta. Now keep in mind that sec squared theta is a special trigonometric identity which is 1 plus tan square theta. Then also cosec square theta is 1 plus cot square theta. So we can rewrite the left hand side as 1 plus tan square theta plus 1 plus cot square theta. So we can have here tan square theta plus 2, that's 1 plus 1 plus cot square theta. So this is the left hand side. Then we can go to the right hand side. Now in the right hand side we have tan theta plus, that's cot theta all squared. So let's expand this as binomial expansion. So if you have tan theta plus cot theta, then you have tan theta plus cot theta, right? So you expand this, you're going to have tan theta plus cot theta tan theta plus cot theta tan theta plus cot square theta. So this should have been tan square theta. That's tan theta times tan theta and so on. So we're going to have tan square theta plus 2 cot theta tan theta. That's this 2 here. We're going to add this to this plus this. Then plus cot square theta. Now we need to know, or you should know, that cot theta is 1 over tan theta, right? Meaning that if you have cot theta tan theta, it will be 1 over tan theta times tan theta. The idea is that this is 1. So cot theta tan theta is 1. So everything here now could be written as tan square theta plus 2 plus cot square theta. Doesn't this look familiar? This is your right hand side and it is exactly what you got to the left hand side. So this is the proof here. So we have proven that what is on the left is exactly what is on the right. So that's the proof of the first one. Now let's go about doing the second one. Alright, here we have the second one. Sine theta all over 1 minus cot theta plus cos theta all over 1 minus tan theta equal to cos theta plus sine theta. Alright, So we saw in the last one that cot theta is 1 over tan theta. Now, tan theta itself is sine theta over cos theta, meaning that cot theta is cos theta over sine theta. So we need to know these identities because you're going to be using them if you want to prove trigonometrical identities, right? So we can rewrite. I'm going to take the left hand side for this problem. So left hand side, this is the left hand side here. So I can rewrite the left hand side as sine theta over 1 minus cot theta is cos theta over sine theta plus cos theta over 1 minus tan theta is what? Sine theta over cos theta. So I'm going to be working with the bottom part now here. So this bottom part here, the LCM is, this is over 1, is sine theta. So 1 in sine theta, you're going to have sine theta. Sine theta times 1 is sine theta. Minus sine theta and sine theta is 1. 1 times cos theta is going to be cos theta. Let me do for this bottom part here also. So this will be cos theta. And you're going to have cos theta minus sine theta here. So this whole thing can be rewritten as sine theta all over sine theta minus cos theta over sine theta. So this can be simplified to this, then plus cos theta over cos theta minus sine theta over cos theta. Alright, I hope that's not too, difficult for you to get. Now, this is a fraction. These are fractions. I have a fraction here and I have a fraction here. So if I pick this first one here, this simply means sine theta divided by cos theta minus. This simply means sine theta divided by sine theta minus cos theta over sine theta, right? So I can simplify this to be sine theta times sine theta over sine theta minus cos theta. So when you change division sign to multiplication, you're going to write the reciprocal. So you end up having sine square theta over sine theta minus cos theta. Good. So this other side, you're going to have cos theta divided by cos theta minus sine theta all over cos theta. So again, you change division to multiplication. I get cos theta all over cos theta minus sine theta. Right, so you multiply, you have cos square theta over cos theta minus sine theta. All right, so now this becomes sine square theta over sine theta minus cos theta plus cos square theta over cos theta minus sine theta. Good. Now if you look at the denominators, they look almost the same. They're not exactly the same, but we know that sine theta minus cos theta, to make them the same, I'm going to do something interesting here. Now this can be rewritten as minus sine theta plus cos theta. So this now can be rewritten as this. I just changed the position of sine theta and cos theta. Then if I bring out the minus sign, I'm going to have sine theta minus cos theta. Okay, so I've managed to change this into this, right? So I'm going to bring it back here and have sine square theta over sine theta minus cos theta plus cos square theta over cos over minus sine theta minus cos theta. Okay, so we go ahead and introduce that minus sign into the expression. This minus sign is going to alter this, and you have minus here, cos square theta over sine theta minus cos theta. So now we have exactly the same denominators, meaning that we can now write this as sine square theta minus cos square theta all over sine theta minus cos theta. Good. Now remember, we're trying to prove that we have this will give you cos theta plus sine theta. Great. Now this is actually difference of two squares. What are the squares? The squares are sine theta minus cos theta, then sine theta plus cos theta, then all over sine theta minus cos theta. As you can see, this and this are the same, so they'll cancel out, leaving you with sine theta plus cos theta. Alright, so this proves that the left hand side is equal to the right hand side. So you could go through the video slowly if you missed any parts, and drop any questions you have in the comment section. Thanks for watching. Catch you on the next one.